Welcome to another A-Level Further Maths revision video. Today we're going to take a look at Further Pure 1 and actually some exam revision. So a mix of questions here from several different chapters in the FP1 book. There is a couple of chapters missing, primarily just because of the fact that it's quite a big book. So there's no chapter 8 or chapter 9 in this. I'm going to definitely do a second exam revision video for this module because I want to kind of cover everything. Okay, so let's jump into it. We've got a mix of things. I think we start off with chapter 2 here, yeah. So we've got a parabola C with this equation y squared is equal to 12x. So we're told the point S is the focus. So we just want to find the coordinates of S to start off with, so for 1 mark. So the whole of this question overall is quite a nice introduction. Let's have a look at this one. So finding the focus, well, you can either memorise this or it is in your formula book, so you don't actually have to memorise it, but it'll save you a bit of time. Your focus is just given as A0. Okay, that's what you've got in your formula book under parabolas. Well, how do we obtain what A is? Well, remember the equation for general parabola is y squared is equal to 4ax. So we need that A there. But notice our equation is y squared is equal to 12x. So 4a is equal to 12, so what must a be? Well, a clearly has to be 3, right? 4a is equal to 12, so a is 12 over 4, giving us 3. So in our case, the coordinates of the focus, so focus of S, is just going to simply be 3, 0. Okay, so a nice easy 1 marker to get us started there, bit of a warm up. Let's jump into the next trickier part. So we've got the line L with the equation y equals 3x, and this intersects C at the point P. So we're asked to find the coordinates of P. So let's have a look at this. So where can we start? Well, we know y is equal to 3x, and we know the equation of our parabola is y squared equals 12x. Well, we've got y here, so if I sub y in, let's see what we get. So y is equal to 3x, so this is 3x squared is equal to 12x. If I expand this, that's 3x times 3x, I'll just multiply it out, that gives us 9x squared. So 9x squared is equal to 12x. Subtracting 12x off both sides now, that'll just give us 9x squared minus 12x is equal to 0. And here now, I'm just going to factorise, right? So I want to obtain what x is. So factorising here, so I can factorise an x out. In fact, what we could do actually is just divide through by 3 first. So if I divide through by 3 first, what will that give us? I'll get 3x squared minus 4x. That's still equal to 0. And now I can factorise it. I mean, you could have factorised here and then divide after. It's completely up to you. But factorising here now, pull an x out, that'll give us 3x minus 4 is equal to 0. So here now, we're going to get two x solutions, okay? So, we're going to get x equal to 0, clearly, and then we're also going to get 3x equal to 4, so x equal to 4 over 3. So, there's two solutions, so therefore, x is equal to 0, and x is equal to, it'd be 3x equals to 4, and then divide 4 by 3, so x equal to 4 over 3. But remember, we want the coordinates, so we have to have a look now what y is when x is these points. Well, we can use y equals 3x again. So when x is 0, clearly y would just be 0. Just subbing that back in to y equals 3x. And then when x is 4 over 3, y is equal to 3 lots of 4 over 3. The 3 will just cancel and we'll just get 4 there. Okay, so them are our two coordinates, but there's a little bit of a catch. We know y has to be greater than 0, so we can't technically have that as a coordinate. Okay, so my actual coordinates here, so therefore P is 4 over 3 and 4. Okay, So that's part B done. And now using that, we can work out part C. So if I just quickly clear all this, let's have a go at that part C here. We're finding the area of the triangle OPS. So, just writing down P again. 4 over 3, 4. So we know it starts at the origin, so you can kind of draw a little sketch if you want. Now, I'm no artist, so just kind of, you know, ignore the bad drawing. So we start at the origin here. That's one of my points. One of my points here is P, which is 4 over 3, so about there, and then up 4. So we can say it's about there. So that's P. And what's my other point? My other point is S, which we worked out right at the start. That's 3, 0. So S is 3, 0. So 3 units along, we can say that's about there. So my triangle looks something like this. Minus my bad drawings. And obviously, the limit should actually be straight, okay? So we just want to know what the area of this triangle is. How would we do that? Well, it's just base times height divided by 2. So remember, your height is the vertical height up, which in our case, as this is P, 4 over 3, 4, that's got to be 4. And then my horizontal length here, what would that be? Well, that's just going to be 0 to 3, right? Because that point there, S, is at 3, 0. So, base times height. So, area is just simply 4 times 3 divided by 2. So that's 12 over 2, which gives us 6. Okay, so 6 units squared for our area there. So, hopefully a nice kind of introduction question. Let's take a look at something a bit more challenging. So this question is looking at when you've got your inequalities. So if I've got 1 over x minus 2 being less than or equal to 2 over x, can we solve this? So the difference here is that you have to use algebra. So it's one of those where you have to use a specific method. Obviously, another way you could have done this would be to sketch the graphs. But because we have to use algebra, if you do a graphical method, you will get 0 marks. So just be careful for that. I know it seems quite obvious here, but people still make that mistake. So it's always something to look out for. So what can I do? Well, 1 over x minus 2 being less than or equal to 2 over x. Well, when we're solving an inequality of this type, we multiply through by both denominators squared. Okay. So we multiply through by both denominators squared. So if I do that, if I multiply this side first, so I've got 1 over x minus 2. I'm going to times that by x squared, x minus 2 squared. Okay, so that's that side multiplied by x squared. So x squared and then x minus 2 squared. It's going to be less than or equal to 2 over x times x squared again, x minus 2 squared. Okay, so we've got the kind of like the basic step down here. Well, from here now, we need to have a look if we can cancel anything. And this is quite a nice question for cancelling. I've got 1 over x minus 2 here, so that will cancel with one of them. And if you look at the right hand side here, the inequality, I've got a 2 over x, so that will cancel with one of them. Okay, so we've got a few things that cancel quite nicely here. So let's rewrite what we've got again. So what we've got currently is x squared times x minus 2. That's less than or equal to 2x times x minus 2 squared. Okay, so let's just double check everything looks okay so far, because if we carry on like this and it's wrong, we might be in trouble. But no, everything's good so far. So here now, don't try expanding anything or anything like that for now. The best step with these kind of questions is to take everything on one side, because what you're hoping to find is that at some point you can factorise things quite nicely and you can draw the polynomial. Okay, so let's take everything onto this left hand side. So x squared x minus 2 minus 2x x minus 2 squared. So this is less than or equal to 0. Okay, and notice now we can actually start factorising, right? Both sides, well, both terms here have at least an x on them, so that's x squared, that's 2x. I've got an x minus 2, and that's an x minus 2 squared. So what I can do here is I can plot an x, and along with that x I can plot an x minus 2. So that's the first bit of factorising there. So what do we times this by now to get this expression? Well, x times x minus 2, well, we need x squared x minus 2. So that's just going to have to be an x, right, to get the x squared. Here, what have I got to times this by? Well, it's going to have to be minus 2 lots of x minus 2, because that's only to the power of 1 here. Okay, so minus 2 lots of x minus 2, like so. And that's our factorising there. This is less than or equal to 0 still. Here, at this point, again, what I'm going to do is I'm going to simplify it in this square bracket. Because what we should hopefully find is that this is just another root. Okay, and what it's kind of pointing out here to me is that we're going to get a cubic polynomial. So this is just x minus 2 still. In this square bracket now, this would be x minus 2x. So that will give me minus x. And then minus 2 times minus 2, that'll give me plus 4. Okay? And perfect. Because what we've got now is we've got a cubic polynomial. A negative one at that, but it's still a polynomial. A cubic at that. So, what can I do now? Well, we can write down where it cuts through the x-axis. Okay, so this should hopefully be quite basic from your A-level maths. One of my solutions has to be 0, so basically it cuts through x-axis at x equals 0. Also cuts through at 2 here, because 2 minus 2, so x equals 2. And then my last one here is this minus x plus 4, so that is x equals 4. Okay, so now I'm going to sketch this, and again, I'm a pretty poor drawer, so it should be nothing spectacular. And again, unless it actually asks for a graphical solution, you know, I wouldn't worry too much about kind of what your graphs look like. Mine are just sketches, just to help illustrate how we get our solutions. So, sketching this polynomial, it's a negative cubic, so how I remember this is I remember a positive one is an n into a u, kind of like that, and then a negative one is a u into an n. Okay, so that might be a bit of a funky way of remembering it, but that's how I used to do it when I was in maths, so that's, I think, a good way of doing it. So because it's negative, we're going to have this shape here. It cuts through at 0, so that's that point there, 2, and 4. Okay, so again, we've just got to sketch this, nothing spectacular. So it comes down to 0, goes underneath, cuts up through at 2, between 2 and 4, it's above the axis, and then we're going underneath again. So the question here now is, where is this cubic less than or equal to 0? So we've got to take a look at our sketch, and again, this, you know, it doesn't have to be perfect, just to give you an idea. So we're looking for, where is it less than the x-axis? Well, at this point here it's above, so it's definitely not that as a solution. Between 0 and 2, that's perfect. We are below the x-axis, so that'll be part of the solution. And then between 2 and 4, we're above the x-axis, so we don't want that. But after x equals 4, everything here, past here, is perfect. My graph's kind of bad. It should be to the right of it like that, but yeah, perfect. So our solution is, so we can write 0, so x between 0 and 2, like we can see here, or x is greater than or equal to 4. Okay, so them are our two solutions. You can write this in set notation if you really want, but I'll just write that, just to save time. So hopefully that's okay. Moving on to the next one here, we have a t substitution question. So 3 cos x minus 4 sin x is equal to 4. So we want to show that it can be written in this this expression here, 7t squared plus 8t plus 1. I forgot the word of a quadratic, right? So we're looking to show that it can be written as a quadratic. And the reason for that is it makes solving it much easier. We can usually just factorise. So let's have a go at this. Now for a question like this, you need to remember your t substitutions, and this is something I would just try and remember. You can learn how to derive them, but in terms of saving time in the exams, you know, time is always tight anyway in these exams. Just kind of memorise your expressions. So sine x, we can write that as 2t over 1 plus t squared. So that's sine x, and cos x we can write as 1 minus t squared over 1 plus t squared. Okay, and that's all we need for this question. It's only in terms of sine and cos. Okay, so subbing our sine and cos in, that's 3 lots of 2t for 1 plus t squared minus, oh, that's terrible. Okay, so I've made a mistake already. I was hoping I wouldn't make one for this video, but ignore me there. What I did is I subbed in the wrong one. So it's 3 lots of 1 minus t squared. 3 lots of 1 minus t squared over 1 plus t squared. Minus, okay, so we'll get it right this time, 2t over 1 plus t squared. Okay, and that's equal to 4. Good stuff. And at this point here now, we need to simplify. The good news is both the denominators are 1 plus t squared, so we can write this over a common denominator to get us started. So this is 3 times 1, and then 3 times minus t squared, so 3 minus 3t squared. Minus 4 times 2t would give us minus 8t there. Okay, and this is all over 1 plus t squared, which is equal to 4. Here now, what I can do is just multiply through by the 1 plus t squared, because we're looking to get 7t squared plus 8t plus 1. At this point here, I've only got minus 3t squared, so we need a bit extra to get there. So 3 minus 3t squared minus 8t is equal to 4 plus 4t squared. And all I do is take everything on this left hand side onto the right hand side, and we will obtain this correct expression. So therefore 4t squared plus 3t squared gives us 7t squared. Minus 8t onto this side, so that's just 0, plus 8t gives us positive 8t. And then 4 take 3 just gives us plus 1. Okay, so we obtain the quadratic as required. Okay, so that's the first 3 marks. And even if you can't get to that bit, we can still solve part B. Okay, so if this is something that you find tricky, don't worry too much. If they give you this, you know, the quadratic that you're working with, we can still go on to solve this. So let's just solve it as if we didn't get given it. So we're only given the quadratic here. How would we solve it? So 7t squared plus 8t plus 1 equals 0. Well, I want to solve this. Well, like I said before, a good way of doing this is often just to factorise. So if I look at this, can I factorise it? Of course I can. The first thing I can do is put 7t here, and then put both my brackets. So we need it to times to give us 1, add to give us 8t. Obviously we've got to take into account this is a 7t at the beginning. Well, the first thing that jumps out here is I need 7t times 1. I mean, both of these are going to be plus 1 anyway, right? Because it needs to times to give us 1. So the only way to doing that is just 1 times 1. So there we go. That gives us our factorised form. So what that actually means now is that t is either minus 1 or t is minus 1 over 7. So that's our t. But obviously we're not finished here. We need to do a bit more because we need to actually find the solutions to the equation. At this point here, all we've actually done is just find t. So remember, we're substituting in tan x over 2 for t. So what we've actually got here is tan x over 2 is equal to minus 1 over 7. And be careful here. Notice we're working in radians. We're between 0 and 2 pi. Okay, so just be careful for that. So here now, this should hopefully not be too tricky. Remember, we're just solving this now for x. So take tan inverse on both sides. So that gives us x over 2 is equal to tan inverse minus 1 over 7. Okay. This doesn't work out as anything particularly nice. It comes out to 2.9997, so that's if you're in radians. And then obviously that's x over 2. Now the one thing I will say here is for this solution, make sure you add pi. So when you actually put this on your calculator, you're going to get minus something, and then you need to add pi to that. Okay, so that gives you 2.997. Because this is x over 2, to actually get x, we need to times it by 2. So therefore, x is equal, round it to 2 decimal places, gives us 6.00. Okay, so that's my first solution for x. And if we do the other one over on this side here, tan x over 2 is equal to minus 1. So again, take tan inverse of both sides. So x over 2 is equal to tan inverse of minus 1. So this one actually does work out as quite a nice one. What this will give you is minus pi over 4. But like I was saying here, you need to add pi to your solution. So you can do that depending on however you're confident. So if you're using your cast diagram or another method, whether it be graphically, that's absolutely fine. But make sure you add pi to these solutions, which comes out to giving you 3 pi over 4. Okay, so again, that's x over 2. So to get x, I need to times this by 2. Okay, so that gives you 6 pi over 4, which we can simplify as being 3 pi over 2. Okay, so there we have it. So that's another question done. A lot of these questions are just taken from the review exercises, so I've just tried to pick as best a mix as we can. So this question here is looking at an ellipse, so conic sections here. So we've got x squared over 16 plus y squared over 9 equals 1. So part A, so another sketching one. I've picked quite a lot of graphical ones here, which is regrettably, seeing as I'm not the best at drawing. So y x. Okay, so how do we sketch an ellipse? Well, what we do is we take a look at our equation. So it's x squared over 16 plus y squared over 9 equals 1. The x squared and the y squared tell you where it's centered at. Okay, because it's just x squared and y squared, think of it in terms of a circle. If you had x squared plus y squared as your circle, it would just be centered at the origin. Same principle here, we're centered at the origin. The next thing to look at is your 16 and your 9. Remember, if you want to know how far across this goes on the x-axis, we take a look at this 16. And how do we do that? We just hit the square root of it, right? So the square root of 16 is 4. So that means we'll go 4 across both sides, and then minus 4 there. Same again for the y-axis here. Take a look at the y squared over 9. You're going to square root that 9. Okay, so square root of 9 is 3. Positive 3. Same again here, that'll be minus 3. And often what you'll see with these questions is your a and your b here, or your a squared and your b squared. They're written in terms of square numbers. Okay, so just to make life easier, they will often do that for you. So here's the point now where I have to sketch this. And at this point here, again, they're not testing where you can't actually, draw a perfect circle, but try your best to make it neat. They just want to see that you've made it clear that it's cutting through at 4 and minus 4 on the x-axis, and then 3 and minus 3 on the y-axis. So let's see what I can do. That's not too bad. It's clearly not centered at the origin on my diagram, but not too bad. You get the idea. So part B, we have to find the value of the eccentricity E. So this is just giving us a formula in your formula book. You don't have to memorize this. It is in your formula book. But write that down if you've not seen it. B squared is equal to A squared 1 minus E squared. Okay. Remember, this is your A squared. And this is your b squared, okay, if you're unsure of that. And that's always the case. Clearly not 16 and 9, but, the number under your x squared and your y squared. So here now, we just need to sub values in to actually solve this. So 9 is equal to 16 minus 1 minus e squared. So be careful here, this e squared, it's not, you know, the e constant that you'd have on your calculator, it's the eccentricity, so just be very careful for that. Multiplying this out now, 9 is equal to 16 minus 16 e squared. So here now, I'm going to take this minus 16 e squared onto this side, onto the left hand side, and then subtract 9 off 16. So what does that give us? What that gives us is 16 e squared is equal to 7. That gives us 7, and then what I'm going to do is I'm going to divide through by 16 on both sides. So therefore, e squared is equal to 7 over 16. And then finally, to get e, I'm just going to square root here. Okay, which is equal to the square root of 7 over 4. Now, just one comment to make here. We only take the positive square root. This might be clear to some people, but remember, eccentricity always has to be positive, right? So we only take the positive square root there. So, just in case you're wondering why we're only taking the positive square root, that's the reason why. You can never have a negative e there. Okay, so the square root of 7 divided by 4. You can give you a solution like this, by the way. That's absolutely fine as well. And then part C, again, just, you know, using your formula book to solve this, we want to state the coordinates of the foci of the ellipse. So this is just given in your formula book. This is actually a really quick question. It's given as positive plus or minus a e 0. Okay. Remember a, well, that's just the square root of a squared, which is just 16. So the square root of 16 is 4. And my e, remember, we just worked that out, it's the square root of 7 over 4. So all you've got to literally do is just plug that in here. So what would that give us? Well, that's literally just plus or minus 4 times root 7 over 4. And then 0 for my y coordinate. These actually do cancel, so all you have to end up with here is plus or minus root 7, 0. As easy as that, you know, nothing too crazy, you know, just using your formula book for that kind of question there. So let's take a look at another one. This one here now, we're looking at L'Hopital's rule. So it's kind of a short question, but it's an, you know, it's an A-level topic, and it can cause some issues. So let's take a look. So question 4 here, so this is actually from the exam at the very back of the book. This is the A-level exam, so not the AS, but the A-level. So the first part, for 1 mark, asks us to explain why we can't use L'Hopital's rule to evaluate the limit currently as it's given in part A. So take a look at it. Hopefully you can spot why, but if not, let's have a look at it. So the first thing I always do is split this up into 2 functions. So my f of x is my numerator. So we've got the limit as x tends to 1. So what that means is we're going to sub x equals 1 in, right, and see what happens. So f of 1, so f of 1 is just my numerator. So 5 lots of 1 to the 4, so that's 5, minus 3 lots of 1 squared, so that's just minus 3, minus 1. Okay, let's do the same with the denominator, g of 1, because before we can start L'Hopital's rule, this has to be 0 over 0. If it's not, we can't quite do it. 11 minus 2 lots of 1, so minus 2, minus 9 lots of 1 cubed, so minus 9. So 11 minus 2 is 9, minus 9 gives us 0. 5 minus 3 minus 1 gives us 1. So here's the predicament. It's not in the required form. Okay, so therefore, not in the correct form. For L'Hopital's rule. Because we require 0 over 0, okay? So that's just your part A done. And you can kind of see how they've modified part B to allow that to be possible then. Instead of it being minus 1, they just change it to minus 2 to ensure that this is 0 over 0. So you could kind of, you know, solve part A if you were really unsure based on part B, just with a little bit of intuition. But let's actually have a go at finding this limit. So it's the limit as x tends to 1, 5x to the 4 minus 3x squared minus 2 over 11 minus 2x minus 9x cubed. First thing I always do is I split this up into two functions, kind of like how we did here. F of x, so that's my numerator, minus 2, and then my g of x is my denominator. That's 11 minus 2x. Okay. First thing to check is that f of 1 and g of 1 is 0 over 0. So f of 1. So I've already done this, but this one will clearly give you 0, right? Because you know, you're just literally subbing in the same thing but subtract an extra 1 off, so that's 0. And then g of 1 again, well, that's just the exact same as what we had last time. So it's 0 over 0. Happy days, we can work with this now. So it's in the required form there. So now, what I'm going to quickly do is just get rid of some of this at the top. Clear a bit of room. And then we can carry on finding the limit here. So, let's have a go at this. So I want to find the limit now. Now, because it's in the correct form, what we can do now is we can differentiate f of x and we can differentiate g of x. So make sure you do them separately. We're not applying quotient rule, we're just doing it separately. So f prime of x and then g prime of x. And then what we'll do is we'll evaluate f prime of x at 1 and then g prime of x at x equals 1 as well. So what do we get when we differentiate this numerator? Again, this is just really basic differentiation. 5 times 4 gives me 20, so that's 20x cubed. In my numerator, what have we got? Minus 3x squared, so that's minus 6x. And then the minus 2 just disappears, right? So all we end up with is 20x cubed minus 6x. My denominator, the 11 just disappears. Minus 2x will just be minus 2. And then minus 9x cubed will be minus 27x squared. Okay. And at this point here now, all we do is evaluate these both at 1. So f prime of 1. So that's 20 times 1 minus 6. So that'll give us 14. G prime of 1. What will that give us? That'll give us minus 2 minus 27. And that'll give us minus 29. Now at this point here, we stop L'Hopital's rule. If this had come out as 0 over 0 again, we would do another iteration of L'Hopital's rule. But because we've got an actual value here, 14 over minus 29, then we've finished. We don't need to apply it again. So therefore, the limit as x tends to 1 of 5x to the 4 is 3x squared minus 1 over 11 minus 2x minus 9x cubed. That's equal to minus 14 over 29. Okay, so I hope that helped. Let's take a look at this question. Final question for today, I think. Oh, we've got one more after. Oh, we've even got another one after. Okay, so quite a lot of questions. So we're given the curve h, which has these equations. X equals 8t and y is equal to 16 over t. Now we're told that this intersects the line with equation y equals basically x over 4 plus 4. So, how do we do this? Well, we've got a few different things that are going on here. The actual thing we really want is the coordinates of the midpoint. Now the first thing I'd do here is I would just sub in my x and my y here into this equation. So what will that look like? Well, this is y equals x over 4 plus 4. And we've got y is equal to 16 over t, and then x equal to 8t. So if we just sub that in, that's going to look like this. 16 over t is equal to 8t over 4 plus 4. Okay, we can simplify here, so that's equals, well, I'll do it underneath actually, sorry, 16 over t, that's equal to 2t plus 4. And here at this point now, I'm going to multiply through by t. So what we're expecting to obtain here is a quadratic in terms of t. We can then solve that for two values of t, and that's going to give us the points a and b here. So that'll give us 2t squared plus 4t. and then take my 16 across, that'd be minus 16. So that's equal to 0. And like I said here, we want to obtain a value for t. Just to make life easier, divide through by 2, because everything's, you know, a multiple of 2. So that's t squared plus 2t minus 8 equals 0. And then factorise here if we can. So we should be able to, yeah, we can do. So that's going to be t plus 4 times t minus 2 is equal to 0. So what that means, therefore, is that t is equal to 2, or t equals minus 4. So we need to consider what happens with both of these here now. So when t is minus 4, what do we get? Well, that's 8 times minus 4, therefore x is equal to minus 32. 8 times minus 4, minus 32. And then y, that's 16 divided by t. So 16 divided by minus 4 gives us minus 4 there. Okay? So when t is minus 4, it's minus 32 minus 4. And then when t is equal to, what was it, 2? What do we get for x and y? Well, x, that's just going to be 8 times 2, so that's 16. And then my y is 16 over 2, which is 8. So that's 16 and 8. So it doesn't matter technically which of these 2 points you label A and B. If we just think about what this problem actually looks like here. So again, just a rough sketch. Basically, we've kind of got a problem like this here. Minus my terrible drawings. And what you've got is a point, a line, a quarter x plus 4. Might look something like that, right? So if I call that point there A, and this one B, for example, that's essentially what we're being asked. We just want to find the midpoint, whatever that be there. Again, this is just a rough sketch, but just to give you an idea of what we're actually looking for. So how do we do that? Well, all we're actually doing here now is some really basic GCSE maths. We're finding the midpoint of these 2 coordinates here. Okay, so remember, add your x coordinates together, divide by 2. Do the same with your y, and we've done the question. So 16 minus 32 divided by 2. So this is actually it, m, so yeah, so m. And then same with the y coordinates, a minus 4 divided by 2. So m. So what will this give us? This will give us minus 16 divided by 2, we get minus a. And then 8 minus 4 would give us 4 divided by 2, and we get 2 there. Okay, so this point here roughly is, you know, your minus a 2 there. So that's your m. Okay, so again, just a rough idea, just see what you're working with. That's what we're kind of looking at for this question. And then moving on to the very final question, we have another t substitution question. So this time we're looking at the identities. So, you know, using your t substitutions, you know, can we show that it's equal or it's identical to another expression? So this one here, again, it's only in terms of sine and cos. So again, just memorize them, guys, honestly, you'll make life so much easier. So all I'm going to do is sub it into my numerator, sub it into my denominator, and then see if we can basically get the expression that we're requiring here. So now, what do we get? Well, 1 plus sine x. So if I just rewrite that. Blah blah blah. What I forgot. So 1 plus sine x. So that's 2t over 1 plus t squared minus 1 minus t squared over 1 plus t squared, and then this is all over sine x plus cos x, so that's 2t 1 plus t squared plus cos x, so plus 1 minus t squared. So all I'm doing is just subbing in my t substitutions here, minus 1. Okay, so at this point here now, I'm going to look to just simplify. The first thing I know is that I've got 1 in the numerator or 1 in the denominator, and because both of these expressions in the numerator and denominator are over 1 plus t squared, what I'm going to do is I'm going to write everything over 1 plus t squared. But notice, if the denominator in my numerator, if that makes sense, so because it's 1 minus t squared over 1 plus t squared, I'm going to have that denominator as well in the denominator, because it's it's a fraction of a fraction like we've got here. So those 1 plus t squared will actually cancel. Okay, so all I'm going to get left with is the numerator as my numerator, and the denominator, or the numerator of the denominator as my denominator. Okay, so that might be a bit confusing in words, but hopefully it'll make more sense when we start working it. So 1 plus t squared, that's that 1 there, plus 2t minus 1 plus t squared. Okay. Dividing this now by, so that's 2t plus 1 minus t squared minus 1 there. So now, what can we do? We can just simplify our terms, right? So I'm losing my voice. We've got to the end of this one. So that's 2t squared plus 2t plus, so the 1's cancel, so nothing else, so it's just 2t squared over 2t. Let's do the same with the denominator. So what I've got here is a minus t squared, got 2t, oh, we forgot an extra term, okay, so that's bad. So this is a minus 1 and then a minus t squared here. Okay, so I nearly forgot that minus t squared, so don't forget that. I'm going to say something's not working. So what we get here is minus 2t squared, minus 2t squared, the 1's cancel, and I just get left with plus 2t here. Okay, this is looking good so far. What I'm going to look to do now is just to factorise my numerator and my denominator. So what would that give us? Well, that's going to give us here 2t squared, so that I can play a 2t at the front, so 2t, so that's going to be t plus 1 in that case here. My denominator, I can play a 2t again, that'd be 1 minus t, so really I should have wrote that as 1 plus t. So if I do it over here, t 1 minus t there. Okay, and we'll close that bracket down here. At this stage, I can actually cancel both of my 2t's, okay? So 2t, cancelling them. Sorry about that, guys, I had to answer the phone. Nobody leaves me alone. So finishing this question off, we got to 1 plus t divided by 1 minus t. Now at this point here, we're not quite finished because this doesn't necessarily show that this is identical to 1 plus sin x over cos x. So what we have to do is use our identities and our substitutions with this right hand side here. So this is 1, so therefore right hand side, this is 1 plus 2t over 1 plus t squared divided by, so that's 1 plus sin x divided by 1 minus t squared over 1 plus t squared, okay? Multiplying this 1 by 1 plus t squared, so it's over a common denominator. And notice this is 1 plus t squared here, and this is a 1 plus t squared here. So they're actually going to cancel it, it'll cancel under that 1 as well. So all I get left with is 1 times 1 plus t squared, so that's 1 plus t squared, plus 2t, divided by 1 minus t squared, okay? At this point now, see if we can spot what's happening. I've got 1 plus t squared plus 2t in the numerator. Well, that's actually an expression we can factorise, right? That's 1 plus, or t plus 1 squared in the numerator. And then your denominator, notice that this is the difference of 2 squares here. So this is 1 minus t and 1 plus t here, okay? With it being t plus 1, or 1 plus t, I can actually cancel one of them with that, so all I get left with is 1 plus t in the numerator, and then 1 minus t in the denominator. And there we have it for 4 marks, okay? So, quite a few questions there. I hope this video's really helped, guys. I'm definitely going to do another one of these revision videos for Further Pure 1, because, there's still a good few chapters that I want to get through. But I hope it's helped. Be sure to like, subscribe, all that good stuff. Cheers, guys.